Right.
Hi, good afternoon, everybody. Thanks for coming to this talk, which will be focused on OpenBMC on HPE servers. I'm here this afternoon with Mike Garrett, who works at HPE as a technologist focused on OpenBMC on ProLiant platforms, and with Vincent Minet, who works at Criteo, and we are collaborating all together to bring OpenBMC to HPE enterprise-class servers. And our main goal for this afternoon is to provide you feedbacks about what happened during the past 2 years.
Yeah. So you might be wondering why two companies like Criteo and HPE are interested in open-source BMC. Well, for Criteo, as an end user, basically, we are getting a bit tired of proprietary firmware and their black box model. We have tens of thousands of BMC, and we simply want more control over them than what we have today. We believe that going with open source firmware is the only way to improve reliability over what we have today. For example, today when there is an issue, we often have a feel of what's the cause, what could be the issue, and what could be the fix. But we don't have access to the source code, and so our actions are limited. If we have access to the source code with the open source firmware, then we will simply be in a much better position to debug the issue and fix it, basically. Access to the source code also will be a very big plus for the security, basically, and that's important for us. Also, having access to the source code means that we are going to be the one building the firmware. And that's going to give us a much better autonomy than what we are used to. It's also going to free us from the release cycle of our dear hardware vendors. But basically, when we want to release the BMC, we just release it, and that's it. In fact, what we are going to do is use more modern methods of development. Basically, we want to bring the whole BMC ecosystem into our internal CI/CD, and when we just commit something, it goes through the CI/CD pipeline and release the BMC through pre-prod, through production, and so on. Yeah, basically that's our goal at the end. It's managing the BMC, releasing firmware and stuff like that, just like we are used to with the Linux system on the host. We don't want any difference there. And I guess that for HPE, well, why are they interested in open source firmware? That's basically because clients like us are asking for open source firmware. So tier 2, government agencies, or even small businesses. I think you see a market there that needs to be addressed. And honestly, from our perspective at Criteo, we are very grateful that you are trying to address that market. So maybe just to give a bit of context, Criteo is probably not a well-known company. We are in the tech sector, and in terms of infrastructure size, we are basically a small tier 2, I would say. We have roughly 10 data centers, 50,000 servers, and we have a strong desire to standardize our infrastructure on open source firmware. We are already using Sonic into production. Basically, all our newer data centers are running full Sonic, and we are working on OpenBMC, that's this talk, and also Linux boot to replace the BIOS of our servers. In the context of our work with HPE here, our target is to migrate all our Gen 10 Plus servers to OpenBMC as soon as it will be possible for production. That's roughly 8K servers there. So basically, yeah, that's a rough idea of what we are doing at Criteo.
Let me take a couple of minutes and update everyone on our relationship with OpenBMC. We started looking at this back in about 2017, and especially during the pandemic, some things got slowed down, but we have signed the Linux Foundation license agreement and have done all the basic porting work for OpenBMC to our ProLiant platforms. We're still in sort of a proof of concept stage. We have not delivered a product yet, but we have ports for the DL360, the DL325, the Apollo 2000 nodes, which Vince is happy about, and we're continuing to work to mature the code base, upstream it, and set the stage for the future. So yeah, like I said, we signed the CCLA, and we've been working with Criteo to unlock a few of their nodes. As you know, our servers typically run ILO 5 firmware, which is proprietary. It's our mature firmware code base. And so there's some special things we have to do to enable OpenBMC on these nodes. But we're in this proof of concept phase, and we've unlocked a few of them and exploring the future with it. And we're also getting a lot more inquiries from customers. So definitely interest in OpenBMC is growing. Go ahead.
So as you can see, I think it's fair to say that HPE has been working on this for a bit of time now, and I think it reflects the challenges that exist to port something like OpenBMC on their ProLiant platform. Regarding an end users like Criteo, the challenges are a bit different. Basically, we can't do that alone. We can't, just take an out-of-the-box OpenBMC offering, snap our finger, and it's there on our server. It's unfortunately a bit more complex than that. We need to partner with the vendors that are selling servers. And we need to build a relationship with them, because it's not as simple as asking, we want OpenBMC on our servers. Often, when you do that, you see that your expectations are a bit unclear, and you need to have a fair discussion with the vendors to explain that, for example, you want to build the firmware yourself. You don't want the vendor to build the firmware, and stuff like that. So again, that's kind of the challenge for an end user like Criteo. You need to discuss a little bit with the vendor, build a relationship, explain what you want to do, basically.
And the key thing there is we don't want it to just deliver OpenBMC firmware on our system. We want you to be able to customize it, build it, debug it yourself. So that's our goal. Among our challenges, OpenBMC is getting fairly mature on certain hardware platforms, but this is an entirely new and distinct platform. HPE servers have a number of distinct differences from other x86 servers. Foremost among those differences is that we have our own HPE Silicon BMC SoC. So instead of running a different piece of hardware, we actually have an in-house ASIC for our BMC. So typically that's designed to run with ILO firmware. And so the process of adapting OpenBMC firmware to run on it involves writing a bunch of drivers. And there's a lot more uplift than there would be just simply porting it to a new platform. It's not just sensors, it's all the drivers as well. So that's coming along nicely. That's I think mostly in place. The big one for us is we have this feature in the ASIC called Silicon Root of Trust. And when the ASIC was designed, it was designed only to run authentic HPE firmware. So this process of putting OpenBMC on the system has proven to be an interesting challenge internally for proof of concepts and also for productization, because obviously we have to come up with an architected transfer of ownership mechanism. And the way the silicon was designed, we don't actually get much help from the silicon today. So we'll explain here in a second what we've done for this proof of concept. And there's still work to do there. And so the other thing is we are planning to upstream everything we're doing, all the ports for DL360, 325, and the Apollo systems will be upstreamed eventually to the Linux Foundation upstream OpenBMC repos. So, okay, this is my most technical slide. So what you see here is sort of an image of the firmware, and I won't make this boring, hopefully, but our ASIC runs this thing called the micro boot block labeled 1 above, and that's identical. That has to be identical. It can never change. So it's identical between our ILO 5 firmware and the OpenBMC port. So what that does is we've created this thing called GXP loader at the top of that stack that looks like ILO firmware, but is very small. And that, in turn, looks at this thing below it called the customer key block. And that contains Criteo's public key for U-boot, It contains an ASIC ID that I'll explain in a second, and it also is wrapped in an HPE signature. So we can run trusted code up through GXP loader and then look and verify the validity of the customer key block. And once we see it's valid, we can then measure U-boot and check the digital signature of U-boot. And from then on, it's Vincent's code to do with as he wishes. So we can provide a secure boot solution up through U-boot, and then the customer can take over from there. Let's talk for a second about the ASIC ID. One of the byproducts of the way we've done this for now is that the customer key block actually contains the unique signature of the ASIC it's going to run on, and that's unique for every system. And that is to protect Criteo, but it's also to protect other customers running Reliant code, because we don't want to be able to if something happened to your key, for instance, someone would be able to build OpenBMC firmware that would run anywhere on our product line, and that would be bad. So anyway, it's a little complex, but that's what we're doing for now, and we're working on some ways to make that more streamlined.
So as you see, there is a big security system here, and the root of trust system that was designed for OpenBMC is very interesting. But it has also consequences for the conversion process. And I'm going to be honest, today it's not as easy as we would like. It involves a bit of a dance. You can see on the right an overview of this process, and basically it goes as this. So as you described, there is a bit of cryptography involved. We need to send our public key to HPE. Once this is done, we need to generate this unique key block for each BMC. So what we do is that we fetch the ASIC ID of each BMC. That's something that is, the regular ILO5 firmware give us access to that information. So once we have the ASIC ID, we send them to HPE, and they send us back the key block for this BMC. Of course, today, that's something that we do manually with tens of thousands of BMC. That's not something that you want to do manually. So we need to automate that process. And today, this is a work in progress. It's not really done. But let's say that this is done, and we can generate this key block at scale. Then we are able to generate an OpenBMC image for each BMC. But we cannot yet flash it on the ILO5, because the regular ILO5 firmware is only able to flash images that have been signed by HPE. And the images for the OpenBMC images for our BMC are something that are signed by our own key. So we need to have an extra step where we are first flashing a custom regular firmware. Just, it's customized to be able to flash images that are signed by Criteo. And only then are we able to flash the OpenBMC image. So it's a bit involved. Fortunately, we only need to do that once. Once this is done, we are in the OpenBMC world, and the next update is just a regular OpenBMC update. But yeah, it is as it is. It's workable, but this is probably something that you will work on for future generations.
Right, this is proof of concept.
Yeah.
Time.
Anyway, I think.
So when the pandemic arrived in 2020, we were collaborating through physical meetings, and we were able to work on real servers at office space. And all of this process broke up, and we wanted to pursue our efforts regarding OpenBMC and just being sure we could deliver something efficient to Criteo and other beta users or proof of concept users. So we had to rewrite a full tool and put in place diverse tools to help us to work from home and develop such solutions. And we ended up to create a project that we call OSF-CI, which has been released under open source license and is under the Open Compute project umbrella currently. So with this tool, you can, from a web browser, test the Reliant systems, recompile an OpenBMC image or a Linux boot image, and validate that it works through an API or through an interactive sessions on real hardware. And this has been really key to help us to enhance OpenBMC support on our platforms and keep the project moving forward. So the pandemic has been bad to all of us, but in some way, it has helped us to improve our process to work efficiently and to automatize the testing process. And we are still under the process to enhance these tools with the test and validation workgroup, which has been set up under the OCP umbrella. So we need a lot of tests now just to be sure that OpenBMC is working properly, and we're expecting the community to deliver some test suite which will be released under open source license within the next couple of months.
We only have about 5 minutes left, so we'll move through this fairly quickly. Status for HPE is we have delivered proof of concept systems running OpenBMC on our standard ProLiant hardware. We've chosen to enable this on our existing platforms, and it does run well on our ASIC. We just need to finish the upstreaming process. The collaboration, I think, is working really well. It's been a lot of fun, and we just need to get some more stuff up.
For example, we've been able to, during this POC, we've been able to fix bugs autonomously. And by bugs, I mean stuff that we were able to reproduce and that you were not able to reproduce in your environment. So typically, the kind of stuff that are a problem for us in production. So we are very happy to be able to see during this POC that one of the motivations or one of the why we are doing OpenBMC that, it's really working. We are able to fix stuff autonomously, so we are very happy about that.
Yeah. Okay.
So yeah, and there is a live demo on the HPE booth, so I think if you want to see that working on the ProLiant server, do not hesitate to go through HPE booth.
Yeah. Well, so real quickly, I mean, we got work to do on the transfer of ownership piece. It's a little awkward right now. Productization stuff in the future, there's still a lot of kinks to work, a lot of decisions to get made within HPE about how to productize this. And we haven't even really talked too much about the issue of circular economy and decommissioning. So a lot of work still to do, but we are where we are today, and I'm pretty happy with it.
Yeah, the warranty question also is a bit open. So
right.
We are able to run our own firmware. How does this, what does it change for the warranty? But these are open questions at the moment.
So I think the most important part regarding this collaboration is to tell you that we want to expand it to anybody who's expecting to run OpenBMC on ProLiant servers. And feel free to get in touch with us. We want to discuss with you and better understand your needs and how we can fulfill it through an open collaboration. The best way to see it running is to come to HPE booth. So Vincent or Criteo people might be around, and you can discuss freely with them about what we have done during the past 2 years and what we are expecting to do during the next couple of months. I must also mention that everything that we do is under an open source license, so nothing is secret. So you can go to Hewlett-Packard GitHub repo and get access to OpenBMC or GXP Linux kernels or patches. You can recompile everything at home or within your corporation, depending on where your compile system is. The CI will be available to any Open Compute members pretty soon. So feel free to get in touch. That's probably the right time to ask, do we have any questions?
There are 2 microphones on either side, so please. And if you wouldn't mind just taking off your mask, because it's kind of muffled when you...
So two-part question. Once you got your drivers working for the ILO or the custom silicon, how was the integration after in the rest of the stack? And then what were some of the things that were getting in the way of upstreaming into BMC?
Those are two great questions. The driver integration has actually been pretty seamless because once it sprouts sysfs files and things like that, most of the rest of OpenBMC just plugs right into it. There's been a few things we've had to mess with, but for the most part, I think that stuff has gone pretty smoothly. As for what's taking so long to upstream, we have a significant number of patches. I don't remember the timeline slide. We actually had a couple of engineers experimenting with this way back in 2017 before we ever went public with the license agreement. So there's some pent-up work there that has to get cleared out.
Were there any particular areas that you had to patch heavily?
Oh yeah, just like, I'll give you an example. The video hardware on our silicon is radically different from anything else you've seen. So, you know, I'm sure the KVM support in OpenBMC was designed for certain well-known BMC ASICs, and this has to
Okay.
be completely different.
But like patchwork for like any of the BMC web or phosphor hardware mod or any of the data
so,
model things?
You know what? There's going to be some minor patches for hardware mod. Most of the stuff that lives above dbus, we're not touching hardly at all. Our goal is to get all that stuff under dbus producing what it's supposed to produce, and hopefully the rest of it will fall into place. There's cosmetic things like the fact that our fans report percent rather than RPM that will result in patches upstream, but those are minor.
Okay, so most of the really material patches were in hardware
Yeah.
compatibility problems.
That's right. We do have patches. There's other areas of our platform that are not like reference boards or other platforms. So there will be some things here and there. Actually, I'm currently in a conversation with somebody around Entity Manager and some of the ways it works. Our Fruit EE problem doesn't look like anybody else's, so things like that.
Good point.
Yeah.
Thank you.
Sure.
So I have a question about a piece kind of depend on the hardware, right? So how OpenBMC address that? For example, each hardware have some kind of optimization for thermal, for whatever they handle erroring. So that's very unique and specific for that particular hardware vendor. So what the strategy moving forward?
So can you repeat the first part of the question again? If there's
that-
special processing for errors?
So OpenBMC, let's say, work on HPE hardware, but their HPE hardware have a certain optimization work well for HPE server. So which part you're willing to share for OpenBMC to adopt to implement that code, or that is still proprietary for?
Well, so, you know, certain RAS cases, certain error cases are handled traditionally a certain HPE kind of way. And I think in the OpenBMC case, as much as possible, we're trying to stick to what's architected in OpenBMC today. If we come up against a particularly difficult thing that we can't change, then we would take that on a case-by-case basis. But you know, my mind goes to fans and thermals.
Yeah.
I mean, we have highly optimized thermals on ProLiants today, and we're actually looking at ways to write code to transition the HPE specific tables that we've got into the OpenBMC Entity Manager, the PID control things. We're going to try to get it as close as we can, but it's going to take us some, you know, work.
Got it.